Welcome back to my YouTube channel. And this is Niharika from 5th SEM Department of CSE Data Science. Here is my new subject, that is computer networks. Here is my topic, that is TCP connection management. Let's an introduction to TCP. Let us learn what is TCP first. TCP is abbreviated as Transmission Control Protocol. It is one of the core protocol of the Internet Protocol suite. It enables reliable communication between devices over a network and is essential for applications that require accurate data transmission such as web browsing, file transfers, and email. Let's see the overview of TCP as an connection oriented protocol. TCP is connection oriented, meaning it requires establishing the connection between devices before data transfer can begin. This connection is set up through a process called the three-way handshake. Being connection oriented allows TCP to manage data transmission in an organized and synchronized way. It ensures both devices are prepared to send and receive the data. The importance of reliability and order in data transmission. That is, TCP ensures reliability by confirming that each packet of data sent is received correctly. If packets are lost or arrived out of order, TCP detects and retransmits them, maintaining the integrity of the data. Then comes the order. Order is crucial because it allows applications to process data in the correct sequence. And TCP number each package to keep track of the order, reconstructing the original message accurately on the receiver's end. Let us move on to the three-way connection establishment. That is, to initiate a reliable connection, TCP uses a process known as three-way handshake. This process enables two devices to synchronize their sequence numbers and confirm they are ready for communication, setting the foundation for an organized data transfer. Steps of the three-way handshake, that is SYN, that is synchronize, SYN, ACK, synchronize, acknowledge, ACK is acknowledge. Let us study this all three in detail in next slides. So we'll we'll go with a detailed three-way handshake steps. That is synchronize. The client initiates the connection by sending an SYN packet to the server. This packet includes an initial sequence number, which allows both sides to keep track of data order and ensure reliability. SYN ACK, that is synchronize acknowledge. The server responds by sending an SYN ACK packet back to the client. The SYN ACK packet acknowledges the client's request and includes the server's initial sequence number, indicating it's ready for communication. Acknowledge comes. The client completes the process by sending an ACK packet to the server. This ACK confirms the connection, and now both client and servers are synchronized and ready to start exchange data. See the flow control overview. That is, flow control in TCP is a mechanism that ensures the sender does not overwhelm the receiver by sending too much of data too quickly. This prevents data loss and helps maintain efficient communication. The purpose of flow control ensures that data is sent at a place that receiver can handle, prevents the receiver's buffer from overflowing, which could lead to data loss and retransmissions. Sliding window mechanism is TCP uses a sliding window to control the rate of data transmission. The window size represents the amount of data that can be sent before receiving an acknowledgement. The receiver advances its window size based on its current capacity and the sender adjusts the data flow accordingly. Start with an sliding window mechanism. That is, sliding window mechanism in TCP is used to control the data between the sender and receiver. allowing the efficient and reliable data transmission. Purpose of the sliding window is it defines the maximum amount of data that can be sent by the sender before needing an acknowledgement from the receiver. By setting a window size, TCP ensures the sender does not overload the receiver, keeping the data flow in synchronized with the receiver's processing capacity. Then comes the dynamic window adjustment. The window size is dynamic and changes based on the receiver's available buffer space and network conditions. The receiver adjusts the window size as its capacity changes, allowing the sender to match the data transmission rate accordingly. So we'll start with the introduction to conjunction control. That is, conjunction control is a TCP in TCP is a set of mechanism designed to prevent network conjunctions, ensuring a data is transmitted effectively without overwhelming the network. Why conjunction control? That is, when too much data is sent into the network too quickly, it can lead to conjunction, causing delays, packet loss, and reduced network performance. TCP conjunction control mechanism aims to balance data throughput with the network stability, maintaining a smooth and reliable communication channels. Then comes the key concepts of conjunctional control, that is conjunctional window. TCP maintains a conjunctional window that limits the amount of data a sender can transmit before receiving an acknowledgement. Thresholds and adjustments. TCP dynamically adjusts the conjunctional based on feedback from the network, adapting and conditions like or delay. Let us see the three phases of conjunctional control. First phase is slow start, then comes the conjunctional avoidance, fast retransmit and recovery. Slow start it starts with a small data rate and increases gradually. Conjunctional avoidance is growth slow down as load increases. Fast retransmit and recovery handles packet loss by quickly resending lost data and stabilizing the connections. So this completes the TCP connection management. So thank you for watching my video.